Day to everyone. Now like this, I am about now to teach on how to use trigonometry function. Now with trigonometry functions, now this when trigonometry, the topic trigonometry is now done in differentiation, in which you can use the functions of sine. You can use functions of trigonometry like sine x, cos x, tan x, cosec x, cot s, and sec x. You can use now all these functions. These are all the functions in trigonometry, but now their role to play here is to find the differentiation, which this is sine of sine. Differentiation of sine will be equals to cos x. Now d of dx of cos now is negative sine x with d on dx of tan. D of dx of tan is equals to sec square x. D on dx of cosec will be equals to negative cosec x cot x. Now d of dx of sec will be equals to sec x tan x. Now d of dx of cot is equals to negative cosec x. Now like you can see all the function and their inverse, the inverse now of the functions of those trigonometry functions. Now you can see from this, now in order, if a value now is given like sin 2x, you cannot just put it as cos x just like that. You cannot just put it as cos x just like that. So you have to. So now here you look, as you can see, this formula dy on dx of sine f of x will be equals to the inverse of sine f of x. The inverse will mean that now like that, as you can see, this our good friend 2 sine of 2x, sine of 2x. Now to get his difference, to get this, now to find his inverse, now the inverse of x now will be the inverse of sine 2x will instead now be 2. This x will the inverse of x alone will become 1. As you can see, like becomes 1. Now you can put sine and you still put the same value. If you want to continue differentiating it like that, you continue taking this 2, you multiply it here, you continue taking this 2, you multiply here in order to gain cos x. Now to gain it, now you have gained like that. Now I will show you more about some examples that can be gained from it. Now an example that can be given is x is equals to sine t on y, which is equal to cos. Now to find dy on dt, you have to first of all find dy on dt. You have to first of all find them. Now you get them dy. Now this y on the cut on dt, this sine cos x. Now to get is my negative sine is sine t, negative sine t. Now you also get that for cos on dt, which will be equal to cos of t, as you can see like that. Now to find the dy on dx, you take d of y on d of t times d of t on d of x. Now like that, if I did by putting, and you take, in order to have that, you have to take an inverse. You have to invert d. You have to invert d of x on d of t, which will give you d of t on d of x. Now these two functions will cancel. For now, it's like that. Then now you're given negative sine of t times the 1 over cos t. Remember, it has been given that in order to get this, you have to find the inverse of this. You have to find this. Okay, that's why you can see it like that. 1 over dx on dt. 1 over dx on dt, as you can see like that. Then now it becomes sine of t all over cos of t. Now you and I know that sine on cos is equivalent to sec, is equivalent to tan. Now that tan value is now the final answer, is a dy on dx of this particular function. Thank you for watching this video.